Hello and welcome once again to the Maths class, Chapter 2, Circles, Standard 10. Today we are going to discuss about intersecting chords of a circle. What is a chord? A chord is a line which joins any 2 points in a circle. These are all chords of a circle. Now, is a diameter a chord of a circle? Yes, diameter joins any 2 points on a circle. So diameter is also a chord of the circle. Diameter is the largest chord of a circle. Let us now think about any 2 chords of a circle. 2 chords in a circle can be in different ways. The 2 chords can be 2 diameters. 2 diameters intersect when they are drawn. And we can see that they are divided into 4 parts. And all the 4 parts are equal. So we have any 2 diameters of a circle intersect at the center. And they are divided into 4 equal parts. Consider chords which are not diameters. Here I have 2 chords drawn inside the circle. They don't seem to meet, but probably they meet outside the circle. Look at the next case. These 2 chords never meet. They are parallel chords. And we have another case where the chords are not diameters and they are meeting inside the circle. Just like in the case of the intersecting diameters, here also the chords when they intersect, they are divided into 4 parts. Certainly, the 4 parts are not equal. But is there a relation between these 4 parts? Look at this picture. A circle with 2 intersecting chords. The chords are not diameters. They are just any 2 chords. The 2 chords, namely AB and CD, are intersecting at a point. Let us say the point is P. The 2 chords are divided into 4 parts, namely PA, PB, PC and PD. We need to know if there is any relation between these 4 parts, PA and PB and PC and PD. Let us consider these 4 parts as 2 sides of 2 different triangles. See, like this. We join these 2 points A and C, and we join the points B and D so that we get 2 different triangles. Now the 4 pieces, that is PA and PC, are falling on one triangle, and PB and PD fall on the other triangle. The 2 triangles are triangle APC and triangle BPD. Let's have a close examination of these triangles, triangle APC and triangle APD. Look at the angles A and angle D. Do you remember what we have studied about such angles in circles? Yes, think about it. That's correct. These are angles in the same arc, and so they have the same measure. Angle A is equal to angle D. In the same way, look the other way around. Look at the angles that are below. The angle B and angle C. Aren't they equal angles? Yes, they are. So in triangle APC and triangle BPD, angle A equals angle D and angle B equals angle C. If 2 angles of a triangle are equal, then of course the third angles will be also equal. Since the angles of the two triangles are equal, we have it that the triangles are similar. In similar triangles, the sides will be in the same ratio. Let us think about the similar sides. If we take PA in triangle APC, its similar side is PD in the triangle BPD. And if we take PC in triangle APC, its similar side is PB in the other triangle. So we have the relation PA by PC equals PD by PB. PA by PC equals PD by PB. Cross multiplying on both sides. We have PA multiplied by PB equals PC multiplied by PD. PA into PB equals PC into PD. Now what are PA, PB, PC and PD? PA, PB, PC and PD are the four parts when the chords intersect. And we have a relation between them. That is PA multiplied by PB. The two parts of the first chord, PA and PB. PA multiplied by PB is equal to PC multiplied by PD. PC and PD are the two parts of the second chord CD. So we have the relation PA multiplied by PB equals PC multiplied by PD. Or in other words, I can say the product of the parts of the chord AB will be the same as the product of the parts of the chord CD. That is quite interesting, isn't it? All we did was to intersect two chords of a circle. We got four parts, and what we have just seen is that those four parts have a relation between them. The products of the parts of the first chord will be the same as the products of the parts of the second chord. This is true for any two chords of a circle. For example, see another circle. The chords are AB and CD. They intersect at the point P. So we can say PA multiplied by PB equals PC multiplied by PD. Look at another circle. Here the chords are CD and EF. Two other chords, CD and EF, meeting at the point, say P. We have the relation CP into PD equals EP into PF. This is another circle. The two chords are XY and AB, meeting at the point Q. Therefore, XQ multiplied by QY will be equal to AQ multiplied by QB. Let us say what we have just seen in a different way. If two chords of a circle intersect within the circle, then the product of the parts of the two chords are equal. Let's do some questions. Here is the first one. In the figure, AB has length 8 centimeters and OA equals 5 centimeters. What is the length of OB? If OC equals 2.5 centimeters, what is the length of OD? What is the length of OB? Come on, you can tell me what is the length of OB. Yes, the chord AB is 8 centimeters and OA is 5 centimeters. So the length of OB will be 8 minus 5, that is 3 centimeters. Now let us consider the intersecting chords. The chords AB and CD here intersects at the point O. The 4 parts, or we know that when 2 chords intersect, we get 4 parts. The 4 parts are OA, OB, OC and OD. And we also know that there is a relation between them. Yes, correct. OA multiplied by OB equals OC multiplied by OD. Now the length of OA is 5. The length of OB is 3. And the length of OC given is 2.5. How, children, are we going to find the length of OD? From the relation, we have 5 multiplied by 3 equals 2.5 multiplied by OD. From which we get OD is equal to 5 multiplied by 3 divided by 2.5. That is 6 centimeters. Hence, the length of OD is 6 centimeters. Here is our second question. PQRS is an isosceles trapezium. What is the relation between the segments made by T on the diagonals? An isosceles trapezium. Can we connect it to our lessons circles? Yes, you're right. We have something on it. Isosceles trapeziums are cyclic, which means we can draw a circle around the 4 points P, Q, R and S. Like this. Now look at the diagonals of the isosceles trapezium. The diagonals are SQ and PR. Aren't they chords of the circle? Can we not say that SQ and PR are intersecting chords of the circle, which meet at the point T? The chords meet at the point T. Then what are the 4 segments which the point T makes? TP, TR, TS and TQ are the 4 segments which the point T makes on the diagonals. Now, since they are intersecting chords of the circle, we have a relation with them. TP multiplied by TR is equal to TS multiplied by TQ. So that becomes our answer. What is the relation between the segments made by T on the diagonals? TP into TR is equal to TS into TQ. The product of the parts of the first chord is equal to the product of the parts of the second chord. Watch the picture carefully. This question is a bit hard to think about. Let's think about it in detail. In the picture, a line through the center of the circle cuts a chord into 2 parts. What is the radius of the circle? We only have a small part from the center, a small line going to the chord, right? And the chord is split into 2 parts, 4 centimeters and 6 centimeters. Now, if we had another chord, we could find a relation between them. Let's make a small change to the figure. I'm extending the small line through the whole circle so that it becomes a chord of the circle. Okay? Now that chord has a part, a radius part, and we don't know the length of the radius. So I just name it as R. So the radius on top of the 5 centimeters is R, and we have a 5 centimeters, and we have a small part that is below the chord. That small part will be R minus 5, because we know the radius is R and there is a small part 5. So the other small part will be R minus 5. Is it clear? Do I need to explain it again? Let me explain it one more time. We have changed the question into 2 chords intersecting in the circle. One of the chords is 10 centimeters because it is 4 and 6, and it's cut into 2 parts, 4 and 6. The other chord is also cut into 2 parts. The part below is R minus 5. Above the first chord as R plus 5. Yes, this part is R and a 5. So we have this long length as R plus 5. And the length below, the small length below, we have already discussed, it is R minus 5. So the second chord is split into 2 parts, R plus 5 and R minus 5. So what are the 4 lengths of the 4 parts? 4, 6, R plus 5, R minus 5. We have our relation PA into PB equals PC into PD. 4 multiplied by 6 equals R plus 5 multiplied by R minus 5. 4 into 6 equals R plus 5 into R minus 5. Now 4 into 6 is 24. 24 equals R square minus 5 squared. 24 equals R squared minus 25. Or R squared equals 25 plus 24. 49. R squared equals 49, from which we get R is equal to 7 centimeters.